Today we are looking at partial fraction decomposition, and we are actually from a partial fraction decomposition. One of it is non-repeated linear factor. So we are going to start with non-repeated linear factor. Now before that, let's introduce partial fraction. Now suppose we have two fractions, the sum of two fractions. Let's say we have 1 over x plus 1 plus 2 or 3 over x minus 2. This is algebraic fraction, this is algebraic fraction. The addition of these two fractions, is going to give us a single fraction. And let's see, what do we do if we take the not same? Our x minus x plus 1, x minus 2. Now we have 1 here, 1 into bracket x plus 1. We eliminate x plus 1. We have remain x minus 2 plus 3. X minus 2, we cancel x minus 2, we remain x plus 1. So we have x plus 1 here. Now, open this bracket, we have x minus 2 plus 3x plus 3. Open this bracket with 3, then we have divided by x plus 1, x minus 2. If you open this bracket of this denominator, we're going to have x squared minus 2x plus x minus 2, and this will give us x squared minus x minus 2. Now, if you add up all this together, we have x plus 3x, this will give us 4x, minus 2 plus 3, that will give us plus 1, divided by the opening of this bracket, which is x squared minus x minus 2. If you look at this now, the addition of these two algebraic fractions lead us to a single fraction. Now, if you are not given a question that is 4x plus 1 divided by x squared minus x minus 2, the reverse of this process here is what we know as what? Partial fraction. Partial fraction. Breaking down a single fraction into its components. Breaking down a single fraction into its various components. That is now we're talking about partial fraction. That is the reverse of this. The reverse of this answer. We are not given this and asking that what is the component of this fraction here. That is when we are going to apply the partial fraction. Now, in solving partial fraction, there are two rules we must follow. That is two conditions. One, the denominator here, we must be able to factorize the denominator. That is one. We must be able to factorize the denominator. Then two, the degree of the numerator must be one less than the degree of the denominator. Now, if you look at this answer here, you're going to see that we are talking about this is x raised to power 1, and here we have x raised to power 2. You notice that this is one less to this degree. If these two conditions can be satisfied, then we are going to go with partial fraction. Now, we are going to look at example under non-repeated linear factors. This is the introduction of what partial fraction is all about. Now we are looking at first example under non-repeated linear factors. Now, we say example 1. Example 1. Resolve 4 into bracket x minus 4 divided by x squared minus 2x minus 3 into partial fractions. We are to resolve this into partial fractions. Now, solution says 4 into bracket x minus 4 divided by x squared minus 2x minus 3 We can write this in just form. We open this bracket and we say 4x 4 times minus 4 minus 16 divided by, this is the quadratic equation. We should use our knowledge of factorizing quadratic equation to look for the root of this quadratic equation. We're going to get the two roots. And the main number is the roots are going to be x plus 1, then x minus 3. Say x plus 1. Say x minus 3. Now from here now, how is our partial fraction is going to look like? Non-repeated linear factor. You can see this is linear and nothing is repeated. Now it says 4x minus 16 over x plus 1, x minus 3 also says a over x plus 1, the first root, plus b over x minus 3, the second root. Why? We are trying to decompose it into its components. And a and b are constant, which we don't know the value. So solving this further, we're now going to solve for the value of a and for the value of b, which are constant. And if we were still dealing with non-repeated linear factors. Our LCM is this x plus 1, x minus 3. By picking the LCM now, we have 4x minus 16. Say 4x minus 16 equals to, we have a into bracket, x plus 1, we eliminate x plus 1 here, eliminate x minus 3. So we have x minus 3 plus b into bracket, x minus 3. We cancel x minus 3 with x plus 1. Say x plus 1. This denominator here, we cancel this denominator. So we have x plus 1, x minus 3, x plus 1, x minus 3. So we have this now. Now from this equation, we're trying to get the value of a and b. Now, I want to eliminate b so that I can get the value of a. And if I want to eliminate b, I can simply make this x to be additive inverse of plus 1. And additive inverse of plus 1 here is minus 1. Therefore, say let x equals to minus 1. And substitute minus 1 for x in all this equation. Therefore, we have 4 into bracket minus 1 minus 16 equals to a into bracket minus 1 minus 3 plus b into bracket, our x is still minus 1, minus 1 plus 1. 4 times minus 1 minus 4 minus 16 equals to a into bracket minus 1 minus 3 will give us minus 4 plus b into bracket minus 1 plus 1 will give us 0. You can see automatically this is eliminated. Now minus 1 minus 16 will give us minus 20 equals to minus 4a equals to minus 4a. Making a the subject of the formula, so we need to have a equals to minus 20 over minus 4. This cancels this, therefore our a equals to 5. Our a equals to 5. Now, we're going to eliminate b. Now, we want to eliminate a so that we can get the value of b. Our target is to eliminate a. And for us to eliminate a, we have to make our x to the additive inverse of this minus 3. And what is the additive inverse of minus 3? That is plus 3. We say let x equals to 3. Now, we're going to substitute this 3 back into this equation here. We're still going to solve the equation, so we have 4 into bracket 3, since our x now is 3, minus 16 equals to a into bracket, our x is 3, 3 minus 3, plus b into bracket, our x is 3, so 3 plus 1. And 4 times 3 will give us 12 minus 16 equals to A into bracket 3 minus 3 give us 0. So we have 0 plus B into bracket 3 plus 1, 4. If you look at this very well, this is automatically eliminated. So now 12 minus 16 will give us minus 4 equals to 4B. Making B the subject, we're going to have B. Yeah, making B the subject, so we're going to have B equals to minus 4 divided by 4. Therefore, B equals to minus 1. B is equals to minus 1. A equals to 5. A equals to 5. Now we'll come back to this partial breakdown of this single fraction. So we're going to have 4x minus 16 divided by x plus 1 into brackets x minus 3 equals to a, and our a now is 5. So we have 5 divided by x plus 1 plus b. What is our b? Our b now is minus 1. That minus is going to affect this positive. Then we have minus 1 over x minus 3. This is the partial fraction of these fraction here. This is the breakdown of this fraction here. Now we are going to look at another example. Let's say example 2. You can still be looking at our payment when I come back to that. Set example 2. Alright. Now example 2. Example 2. Resolve 3x divided by 2x squared minus x minus 1 into partial fraction. We have to resolve this into partial fraction. And now we will say, okay, solution. Solution. I say 3x divided by 2x squared minus x minus 1. 2x squared minus x minus 1. What can we do about this? Now, if you look at the denominator here, it's 1 less than the degree of the denominator here. That one is satisfied. 2. Can we factorize this? Can we factorize this using factorization method of solving quadratic equation? If you factorize this, 2x squared minus x minus 1, what are you going to have? The factorization of 2x squared minus x minus 1. And if you look at it very well, this is supposed to give us, now let's say 2x squared minus x minus 1. This is 2x squared minus x minus 1. We can treat this to be 2. Just say 2x squared plus 1, or let's say 2x squared plus x minus 2x. Yes, then we have a minus 1. X is common here, we have x into bracket 2x plus 1. What is common here? Minus is common, let's say minus 1 into bracket, say 2x plus 1. So our root here is 2x plus 1, because we have here 2x plus 1 into bracket x minus 1. So the root of this quadratic equation here is 2x plus 1, x minus 1. So therefore, we write in this one says 3x divided by 2x squared minus x. Okay, since we already have this root, there is no need for us to write this again. We just write this 2x plus 1 into bracket x minus 1. And this is equivalent to a over 2x plus 1 plus b over x minus 1. So we are going to do this now. A divided by 2x plus 1 plus b divided by x minus 1. Now what I want to do is say 3x equals to what we have here is what we have here. Before we even get to this, we have to keep the LCM here. So a into bracket 2x plus 1 will need 2x plus 1 will need x minus 1. So x minus 1 plus b into bracket x minus 1 will need x minus 1 will need 2x plus 1. This is 2x plus 1. Okay, this is already divided by 2x plus 1 into bracket x minus 1, isn't it? Now, by the time we do the LCM, let's say the LCM is this, we have 2x plus 1 into bracket x minus 1. Because we use LCM, that's why we're able to arrive here. Now, if you look at what we have here and what we have here, you notice that they are the same. So this will cancel this. That is why we don't really know, we do not need to bother ourselves and writing this out. So we just have 3x equals to a into bracket x minus 1 plus b into bracket 2x plus 1. The method we used in the first example is to eliminate either of these two constants. Now, in this particular example, we are not going to eliminate anything. We are going to use comparison of the two sides of two equations. And in doing that, we are going to expand this. It says 3x equals to ax minus a plus 2bx plus b. Now, here we have 3x equals to, just with x, we have ax, 2bx. Say ax plus 2bx, now minus a plus b. We try to connect them together. Now, from that point, we have 3x equals to, if I factorize x here, I'm going to have a plus 2b into bracket x. I've already factorized x. Then we have minus a plus b, which are the constants. Now, from this point, it says we are now going to compare this side of the equation to this side of the equation. Now, here we have a plus 2b, isn't it? The coefficient of x here is a plus 2b equals to, the coefficient of x here is 3. Let's say 3. We compare the coefficient of x here, we equate the coefficient of x here to the coefficient of x here. Now, we have other constants without any x, which is minus a plus b equals to, constant without x, we're going to equate it with the constant without x here, and we note that the constant without x here is 0. There is nothing here. Apart from this 3x, other constants are just 0. So we equate this to be equals to 0. Let's say this is equation 1, and this is equation 2. Now, from equation 2, from equation 2, we can make b the subject here. And if we make b the subject, we say b equals to A. Can we see that? Now, substitute A for B in equation what? Equation 1 here. Therefore, we're going to have, now we are substituting A for B in equation 1. Instead of writing A, we write B because B equals to A. Instead of A, we say B equals to 2B equals to 3. Or rather, this is B plus 2B equals to 3. B plus 2 will give us 3B equals to 3. Making B the subject, we are going to have B equals to 3 divided by 3. Therefore, what is our B? B equals to 1. If B equals to 1, now what is A? If B equals to 1, what is A? Since here B equals to A equals to B. Therefore, our A is also equals to 1. This method of comparing the two equations together led us to this simultaneous equation. And using the number of simultaneous equation, you should know that you can either use the elimination method or substitution method. So, in short, we already know the most of our constants, A to the 1, B to the 1. Now we go back to this and write 3x divided by 2x squared minus x minus 1 equals to, instead of A now, just write 1 divided by 2x plus 1 plus b. Instead of writing b, our b equals to 1. It says 1 divided by, what is the denominator? It says x minus 1. So this is the breakdown. The breakdown of this single fraction here. And the process of breaking down single fraction into its complement is what we are treating, partial fraction. We are still under non-repeated linear factors. Thank you for watching.